At 6:47 on the morning of September 23, 1883, James Richardson stood beside the first grain elevator ever constructed on the Canadian prairies. Watching farmers queue their wagons 200 meters down the dirt track in Gretna, Manitoba. 34 years old, 6 years in the grain business. He was about to test whether a mechanical elevator system could replace the backbreaking manual loading that had limited prairie wheat exports since homesteaders first arrived. The elevator was a wooden structure 12 meters tall with a capacity of 2,000 bushels, approximately 54 tons. Inside, a gasoline engine drove a belt system that lifted grain in buckets from the receiving pit to storage bins, then gravity-fed grain through spouts into railway boxcars. The entire process, receiving grain from wagons, cleaning, storing, marsh, and loading rail cars, could theoretically be completed by 3 men instead of the 20 required for manual handling. The Canadian Pacific Railway had reached Gretna in 1882, creating rail access to Thunder Bay, where grain could be loaded onto ships for transport through the Great Lakes to eastern markets. But the rail connection was useless if grain couldn't be loaded efficiently. Farmers delivered wheat in individual wagon loads of 40 to 60 bushels. Manually shoveling that grain from wagons into boxcars took hours per wagon. Richardson's elevator would either prove that mechanized handling could make prairie wheat exports economically viable, or demonstrate that the technology wasn't ready for Canadian conditions where dust, cold, and isolation destroyed delicate machinery. The first farmer pulled his wagon onto the scale platform. The workers opened the bottom dump gate. Wheat poured into the receiving pit. The elevator engine started. Buckets began lifting grain toward the bins. The system worked. Within 6 hours, Richardson's elevator had processed 18 wagon loads, work that would have required 3 days of manual shoveling. Prairie grain handling had entered the industrial age. The problem began in 1874, when the first wheat harvests proved that prairie soil could produce grain in commercial quantities. Homesteaders flooded into Manitoba, Saskatchewan, and Alberta, planting wheat on land that had been tall-grass prairie for 10,000 years. By 1880, prairie farmers were harvesting 2 million bushels annually. But getting that wheat to market required infrastructure that didn't exist. Farmers hauled grain by wagon to the nearest railway station, distances that could exceed 50 kilometers. At the station, grain was manually shoveled from wagons into railway boxcars for shipment east. The process was slow, labor-intensive, and created massive bottlenecks during harvest when thousands of farmers arrived simultaneously. The Canadian Pacific Railway understood that grain traffic would determine whether their transcontinental line succeeded financially. William Van Horn, CPR's general manager, encouraged grain elevator construction by offering land beside stations and guaranteed rail service. James Richardson built Canada's first country elevator at Gretna in 1883. The success convinced others to follow. By 1890, 211 grain elevators dotted the prairies along CPR lines. By 1900, the number had grown to 447. By 1915, farmers could deliver grain to one of 2,842 country elevators, an average spacing of less than 15 kilometers. Each elevator followed Richardson's basic design. Wooden structure with mechanical bucket elevator, storage bins, and gravity feed loading. Capacity ranged from 2,000 to 30,000 bushels. The elevators became the defining architectural feature of prairie towns. Vertical wooden structures visible from 10 kilometers across flat grassland. Chief Elevator Engineer Frank Partridge, 42 years old in 1905, specialist in bulk material handling, standardized elevator design across Western Canada. Partridge's specifications included fire protection systems, dust control, and grading equipment that separated wheat by quality. His designs reduced construction costs while improving safety and efficiency. But country elevators were only the first step. Grain still had to reach ocean vessels. If you want to see how Canada built the world's most efficient grain handling system from prairie farms to global markets, please hit that like button. It helps us share more forgotten stories like this. And please subscribe if you haven't already. Back to Canada's grain system. The terminal elevators at Thunder Bay solved the critical transfer problem, moving grain from railway boxcars onto ships without manual handling. Chief terminal designer Robert Spence, 48 years old in 1902, veteran of Great Lakes shipping, designed terminals where rail cars dumped grain directly into receiving pits connected to bucket elevators that lifted grain 50 meters to storage bins, then gravity-fed grain through loading spouts into ship holds. With the first Thunder Bay terminal opened in 1883 with capacity for 500,000 bushels. By 1915, Thunder Bay had 15 terminals with combined capacity of 45 million bushels, enough to store the entire prairie harvest. Loading rates were extraordinary. A terminal could receive grain from 100 rail cars per day and load a ship at 25,000 bushels per hour. A vessel carrying 200,000 bushels could be loaded in 8 hours, work that would have required weeks of manual shoveling. The system's efficiency depended on continuous movement. Grain flowed from farms to country elevators, to trains to terminal elevators, to ships to ocean vessels. Each transfer mechanized, each step coordinated. Bottlenecks anywhere in the chain created cascading delays. The Canadian Wheat Board, established in 1935, added centralized coordination. The board purchased all prairie wheat, allocated storage, and scheduled rail movements to prevent congestion. The system became a planned logistics network rather than chaotic competition. By 1950, Canada was exporting 15 million tons of grain annually to 40 countries. The system had transformed Canada into one of the world's major breadbaskets. Modern grain handling evolved dramatically after 1970. Country elevators consolidated from 2,842 small structures to approximately 300 high-throughput facilities. Modern elevators can receive grain from trucks carrying 40 tons, clean and dry grain using computerized systems, and store 10,000 to 30,000 tons. Rail service shifted from boxcars to unit trains. 110-car dedicated grain trains weighing 12,000 tons that run directly from elevator to port without intermediate switching. No unit trains reduced transportation costs and improved efficiency, but required elevators to load entire trains, a capability that small country elevators couldn't provide. The old wooden elevators disappeared. Farmers demolished structures that had served communities for 80 years, replacing them with concrete and steel facilities designed for mechanized agriculture and unit train logistics. Terminal capacity expanded at Vancouver, and Prince Rupert as Pacific markets became increasingly important. Vancouver terminals can now receive grain by unit train, store 1.5 million tons, and load vessels at 8,000 tons per hour, enough to fill a Panamax bulk carrier in 24 hours. Today, Canada's grain system moves over 50 million tons annually from prairie farms to over 70 countries. The system comprises more than 300 licensed primary elevators and dedicated unit train service from CN and CP, and terminal capacity exceeding 3 million tons of combined storage. Canada ranks among the world's top 5 grain exporters. Canadian wheat feeds populations in Asia, Africa, and South America. Canadian canola supplies food manufacturers globally. Canadian pulses provide protein across the Middle East. And the entire system depends on elevators, railroads, and terminals functioning normally. A systemic failure during harvest season, whether from railroad strike, port closure or coordinated infrastructure failures, would immediately strand millions of tons of grain in farm storage, collapse farm gate prices, and disrupt global food supply chains. Farmers would fill on-farm storage within 2 weeks of harvest start. Grain deliveries to elevators would stop. The combines would shut down mid-harvest as farmers ran out of storage space. The economic impact to prairie agriculture would exceed $200 million per week. Global markets would react immediately. Countries dependent on Canadian wheat, including Algeria, Indonesia, and Japan, would face supply shortages. Prices would spike. Alternative suppliers in Australia, Argentina, and Ukraine would increase prices to capture market share. The 2023 to 2024 railroad labor disputes demonstrated this vulnerability. When CN and CP threatened simultaneous strikes, grain movement stopped preemptively. Elevators halted deliveries. Farmers postponed harvest. The federal government imposed binding arbitration after 48 hours to prevent economic catastrophe. Unlike manufactured goods with inventory buffers, grain systems operate on tight, just-in-time logistics. This harvest lasts 6 to 8 weeks. Grain must move from farms to ports during that window or storage capacity saturates. The system has minimal redundancy. James Richardson continued building grain elevators until his death in 1939 at age 90. His company, James Richardson and Sons, operated grain elevators across Western Canada for over 100 years before exiting the business in 1996. The Gretna elevator he built in 1883 operated until 1978, 95 years of continuous service. Frank Partridge retired from elevator engineering in 1934 after standardizing designs that became the template for Canadian country elevators. He died in 1951, age 88. His fire protection systems prevented countless elevator explosions, a constant hazard when grain dust ignited. Robert Spence continued designing terminal elevators until 1928. He died in 1942, age 88. And the Thunder Bay terminals he engineered handled grain for 70 years before containerization and Panama Canal expansion shifted volumes to Pacific ports. Canada's grain system operates continuously during harvest season. Farmers deliver wheat to elevators 18 hours per day. Unit trains depart every 8 hours for Vancouver, Thunder Bay, and Prince Rupert. Terminal operators load vessels 24 hours per day, trusting that grain continues flowing from the prairies. And somewhere on the Saskatchewan plains, a farmer is dumping wheat from a truck into a modern concrete elevator. The same fundamental transaction James Richardson pioneered in Gretna 141 years ago. Still essential to Canadian agriculture and global food security. The system continues. The world depends on it continuing. If this story moved you the way it moved us, do me a favor, hit that like button. Every single like tells YouTube to show this story to more people. Hit subscribe and turn on notifications. We're rescuing forgotten stories from dusty archives every single day. Stories about infrastructure that feeds nations. Real people. Real engineering. Real global impact. Drop a comment right now and tell us where you're watching from. Are you watching from the United States, United Kingdom, Canada, Australia? Our community stretches across the entire world. You're not just a viewer, you're part of keeping these memories alive. Tell us your location. Tell us if you've worked in agriculture, grain handling, or logistics. Just let us know you're here. Thank you for watching, and thank you for making sure James Richardson, Frank Partridge, and the engineers who built Canada's grain system don't disappear into silence.